Beautiful people, and welcome. In this video, we are continuing our unit on graphing quadratic equations, graphing quadratic functions. In this video, we are specifically going to look at intercept form. Now, intercept form will look something like this, where you have y equals a times, and you'll see two bubbles, two parenthesis groupings. One of them will have x minus a number or plus. The other one will have x minus or plus a different number. Now, those numbers could be potentially the same. If they are, that's fine. But what you're going to do with those bubbles is you're going to find the x-intercept. So the way to do that is, we kind of did this previously. We're going to set each grouping, each parenthesis, each bubble equal to 0. Once we set them equal to 0, you're going to solve for your x values. These are going to be your x-intercepts, not your y. So these are your points on the x-axis. Once we have that, we are going to solve. So if this is, for example, if I have a plus p, I'm going to subtract. If I have a minus, I'm going to add. So in this case, we're going to have x is p. We're going to add q. Now, the easiest way to do this is if you have a number here and a number here, it's always going to be opposite of what you see. So if you see a positive number, your x value is in fact going to be negative. And if you see a negative number, your x is actually going to be positive. So it's opposite of what you see. For step number 2, you're going to find the axis of symmetry. Now, it's different than your standard equation. So your axis of symmetry is you take those two numbers, you add them together, and then divide by 2. Now, for your two numbers, it's always opposite of what you see. So make sure that if it's inside the bubble, inside the parentheses, you take the opposite of the number you see. Again, so if you see a positive 3 inside the parenthesis, you're actually using a negative 3 here. Once you have found the axis of symmetry, you're going to find the vertex points. Very similarly, how we found the vertex point in the standard version is you're taking your axis of symmetry value, your x value, and you're plugging it into the original equation and solving for y. Once we have our y and our x, so our vertex point, our axis of symmetry, and our x-intercepts, we're going to connect the points with a curve, plot it on the x and y axis in the graph, and then you are done. So let's go ahead and try out an example here. So here is example number 1. Now again, I'm going to follow through with those steps. Step number 1 is to find the x-intercepts. So what I'm going to do is I'm going to set this bubble and this bubble equal to 0. And I'm going to solve. Now, you do not have to show me work if you are in my class, because you can do this by visually seeing. It's always opposite the number that you see. So if you see a minus 4 here, it's going to be a positive 4. So if you see a plus 5 here, it's going to be a minus 5. So these are your x-intercepts. Now, an intercept is a point. So we're going to say one of our x-intercepts is 4, 0. The other intercept is going to be at negative 5, 0. Step number 2 is to find the axis of symmetry. So that means I have x equals to p plus q divided by 2. Now remember, it's opposite of what you see. So for your p and q values, let's change colors here. I'll stay with green. If you see a minus 4, that means you have a positive 4. If you see a plus 5, that means you have a minus 5. So this is your P, this is your Q. Again, opposite of what you see. You're going to divide that by 2. Now this one doesn't look like it's going to give us a pretty number. That's okay. We can leave it as a fraction. Or actually, is it going to give us a fraction? I think it is. So we have 4 and negative 5. That gives us a negative 1. And we have divided by 2. So it gives us a fraction of negative 1/2. Again, that is okay. Fractions are also our friends. So for step number 3 is we find the vertex point. For the vertex point, we're going to take our x value, plug it into the original equation. So I have 3 here. So that's step number 3. So I have original equation is y equals 3 times x minus 4 times x plus 5. So I have 3 times, again, inside I have a negative 1/2 minus 4. And here I have x, which is negative 1/2, plus 5. Now using your calculator is okay. Just make sure that if it's a fraction, it stays a fraction. So I have negative 1/2 minus 4, and that gives us negative 4 1/2. This one here, I have a negative 1/2 plus 5, which gives me a positive 4 1/2. So 4 1/2 times 4 1/2, that gives me 20 1/4. Again, I am using my calculator on this. It's okay to use your calculator. And I'm going to multiply that by 3, which gives me 60 3/4. This is your output. We'll do a prettier example here in a little bit for example 2. Hopefully example number 2 is going to give us something much prettier. So that's step number 3, and then we're pretty much set. Oh, I'm going to remove step number 2. We'll do that in a different page, so don't worry about step number 2 here. So let's go ahead and sketch this out. Oh, you guys can't see that. I'm going to shift this up. All right, so what do we have here? We have 2 x-intercepts. So we have an intercept at x equals 4 here, and we have an intercept at 1, 2, 3, 4, 5 at negative 5. So those are my 2 intercepts. I also have an axis of symmetry at negative 1/2. So if this is 1, negative 1/2 is somewhere here-ish. Again, we're going to try to be as precise as possible, but I understand fractions are difficult to sketch, so we're going to guesstimate where it is. So if this is negative 1, 1/2 is somewhere there. Then we have our vertex point. So where's our vertex? Our vertex is at 60 3/4. Now that is a very long, positive. It's going all the way up, all the way over there, and it should be negative. If I go back up here, I have a negative times a positive, so this should be negative, and this should be negative here. That was my mistake. It should be negative. So I'm going to guesstimate. Now the easiest way to guesstimate is just say, hey, I'm not labeling my y. I'm just going to say, bam, somewhere over here is 60 3/4. So when my input was negative 1/2, my output was a negative 60 3/4. So your vertex is always going to be on your axis of symmetry. You just basically need to know what the y value of it is. So once we're here, we're going to connect. Sketch this out. Connect to these two. Make sure you have arrows on your curve. And you have scratched your quadratic equation. Now again, take a look at your a value. Let's shift this down. For your a value, your 3 was positive. So that means that you will have a increasing function, meaning your quadratic curve, should be facing up like a happy face. And there it is. All right, let's do one more example. Let's see if we can come up with a prettier example with easier numbers. So let's say we have example 2. Let's say we have a negative 2 times x minus 4 and x plus 2. And that's equal to y. Step number 1 is to find your x-intercepts. And again, your x-intercepts is taking each bubble, setting it equal to 0 and solving. Now you don't have to show me this if you're in my class. You can just look at this. It's always going to be the opposite numbers of what you see. So for your first x-intercept, you're going to have x is equal to positive 4 because I see a negative 4, therefore the x value is a positive. And x is equal to, I see a positive 2, therefore x is going to be a minus 2. So intercepts are points, so that means I'm going to have a point at 4, 0, and I'm going to have a point at negative 2, 0. That is step number 1. Step number 2 is asking to find the axis of symmetry. Axis of symmetry is x equals p, which is again opposite of what you see, so I have a 4, and I'm adding that to q, which is again opposite of what you see, so if I see a positive 2, I am writing a negative number. So here's q, here's p, and I'm going to divide that by 2. So 4 minus 2 divided by 2, which gives me 2 divided by 2, which is 1, and that is our x value. That is your axis of symmetry. Step number 3 is to find your vertex point, which is taking your axis of symmetry and plugging it into your original equation. Now here's our original equation. Make sure that when you're plugging it in, you have bubbles around your x values in case you have a negative for your x. So I have negative 2 times x minus 4 times x plus 2. I have created bubbles so that way I can put my 1 in here. And then we're going to simplify. So I have 1 minus 4. Oop, forgot my negative 2. 1 minus 4, that is negative 3. 1 plus 2, that is positive 3. So here I'm going to use my calculator and say negative 2 times negative 3 times positive 3. That gives us 18. So then vertex, again, 18 means nothing. What we have is our vertex at input of 1, output of 18. And so now we are at step number 4, where we sketch and connect. So let's sketch this out. I'm going to shift this a little higher. And again, our y value is a little bit on the higher side, right? It's 18. That's okay. We're not going to label all of our y axis. We're just going to label where 18 is around. So if we have our intercepts at 4, 1, 2, 3, 4, and we have it at negative 2, 1, 2, that means our axis of symmetry is at x equals 1, which is here. And our vertex is at 1, 18. So let's make 18 here. 18 is a big number, so it's going to be pretty high up on the y-axis. And that's pretty much it. So we're going to do a smooth U and connect. Now we know it's going to be facing downward because our a value was negative. So let's shift back up to our original equation. Our original a value was a negative 2, so therefore it's going to be a decreasing function, meaning our arrows are going to be going downhill. So we have something like that. All right, beautiful people, thank you so much for watching. I will see you in the next video where we do more examples. Bye!